Hi, welcome back. Today we're going to look at Unit 6B, Day 3. We're going to find angles using trig. Before we do that, we want to review what we did yesterday so we can see how today and yesterday kind of relate with each other. So we're going to review that we can find missing sides of a right triangle if we know an angle, and it does need to be an acute angle of the right triangle because we already know it has a right angle, and then we need one side. Now, look at my reminder. Don't forget to make sure your calculator is in degree mode. And the calculator I really like to use is the one that comes with the CMS. When you open it up, you're going to see like this, and it'll remind you, click the calculator icon above. You'll get your calculator. You can drag it to one side, and then you can minimize your screen around it so you can see what you're still working on. As you're working, you have your calculator and your assignment side by side so you can work with both. Okay, so to make sure we're in degrees, if you forgot how to do that, make sure you ask with me when you're working on the assignment or go back and look at one of these videos, because each time I will remind you, you're going to click on mode, and every time you open it, you're going to have to do this because it defaults. So we're going to arrow down to degree. And then notice radian is still highlighted. We want to make sure that gets highlighted. So we click on enter, and now you can see radian is no longer highlighted, degree is highlighted. And to get back to our calculator screen, we're going to quit out of this menu by hitting second and then that mode again. So we quit. Okay. All right. So now let's look at this one. The first thing we said we want to do if we're trying to find a side yesterday is we said we identify our hypotenuse, which is always going to be across from the right angle. That's my hypotenuse. And then we identify which angle we're standing at. And so I can see the acute angle that I know is this one over here, my 31 degrees. So I'm going to go ahead, and that's where I'm going to label my triangle from, is in relation to this 31 degree angle right here. And then from there, I'm going to put my pen down and highlight the side that's not the hypotenuse, because that is the side of the triangle that's adjacent to me, which means the one that's all the way on the opposite side, as far away as I can possibly get, is the opposite of where I'm standing. Then we said the next thing we want to do is compare this to so, ka, toa. Okay, so that we can see which trig function we're going to be using to find our missing sides. So when I look at this, I can see that I am trying to find the adjacent side. That is my goal. So I'm going to put checks by the adjacent sides. And then the side that I know how long it is this opposite side. So I'm going to put checks by the O's. And then which trig function, sine, cosine, or tangent has two checks? That's going to be the tangent. So I know I'm going to be working with tangent of how many degrees? 31 degrees is going to equal opposite over adjacent. My opposite is 17. Over the adjacent is x. Okay, so there's my trig function ready to go. My next step was to make it into a proportion by putting the left side over 1 so that I can cross multiply. When I cross multiply, x times the tangent of 31 equals 17 times 1. And then we had to step back for a moment and say, can I go straight to my calculator or do I need to divide? If this said x equals, then I can go straight to my calculator. But it says x times something. We want x all by itself. So to untimes, right, the opposite, or what we say the inverse of multiplication, the opposite of multiplication is division. So I do want to divide both sides by that tangent of 31. Divide by the tangent of 31. So these two will cancel, and on the left-hand side, I'll just have my x. And on the right-hand side, I have tangent 17 divided by the tangent of 31. So I'm going to come over to my calculator and do that. 17 divided by the tangent of 31. And remember, it opens up that parentheses for me. Sometimes I need to close it, sometimes I don't. A lot like wearing your seatbelt. A lot of the times, if we don't close it, we're not going to get the wrong answer. but it's always best to put that seatbelt on. So I'm going to close that parentheses. And when I hit enter, I'm going to see that x equals 28.292. And then after that 2 is a 7. So I do want to bump that up to 293. 293. Okay, so that is what we did yesterday. Okay, today we are going to be given two sides and we're going to be trying to figure out how big was that angle. So we're going to try to figure out what is this number that goes next to the trig function that will give us the ratio of the two sides that we know. Okay, and to do that, we use what's called an inverse. Just like there's an inverse to addition and multiplication, which means like the way to undo it. The inverse is how we undo something. So the inverse to addition is subtraction, because subtraction undoes addition. The inverse to multiplication is division, because division undoes multiplication, right? That's why we divided by the tangent here, because it undoes this multiplication. There's also an inverse to trigonometry. And when we use it, we take what's called the inverse of that function. And the way we note that we're doing the inverse is, see this little -1 there? That's what tells me I'm doing the inverse of sine, the inverse of cosine, the inverse of tangent. Okay, so that's what tells me that. And then inside the parentheses, remember every time you open a trig function, it gives you parentheses. Inside the parentheses is where you're going to put your ratio. It's still the same exact ratio, SOH, so, ka, TOA. It's still the same acronym, so you don't have to learn anything new. We're still using so, ka, TOA. It's just we're switching the position of the ratio or the fraction with the degrees. My ratio is going to go inside the parentheses with the trig function, and the degrees is going to go outside. The key, though, is that little -1. You have to make sure when you're trying to find the angle that you use that little -1. So let's see how we apply that to some problems. All right, the first thing we're going to do, it starts out exactly the same as when we were trying to find an angle, where the first thing you need to do is label your hypotenuse. So that's the first thing I'm going to do every time. Okay, then from there you need to find we found the acute angle that we were standing at by looking to see which acute angle we knew. But this time we're trying to find one. We don't know either one, but it tells me where I'm standing. I want to find angle E, so that's where I'm going to stand. I'm going to stand right here at angle E. Okay, which means if I put my pen down there and I highlight the side that's not the hypotenuse that I haven't already labeled, that is the side that I'm standing right next to, so that is the adjacent side. Okay, then the side that's left, the one that's all the way across from the triangle, that is my opposite side. Okay, so I've got hypotenuse, I have opposite, and adjacent. Now I need to figure out which trig function out of sine, so, ka, cosine, TOA, tangent, which one do I want to use? So just like last time, I said, well, let me circle the side that I know, but I have two sides that I know. I know the adjacent is 5, and I know the opposite is 12. So I'm going to circle those two. I know the adjacent is 5. I know the opposite is 12. So just like last time, I say, which one do I know both of? That's the trig function I want to use. I want to use the tangent of that angle that we don't know is going to equal the opposite over the adjacent. So my opposite is 12 over the adjacent. Now here's my problem. If I were to go and put this over 1, when I cross multiply, there's no way to undo that E from the tangent. They are stuck together. Okay, you can't separate them. So instead of doing this, we do the inverse to separate these two, to kind of switch these places. Okay, so what we're going to do is we're going to write it as the inverse. I'm going to do the inverse tangent. So tangent with that little -1 of this answer, 12 over 5, is going to equal that angle E. So now, how do I put this in the calculator? Okay, so to put that in the calculator, when I come over here, notice sine, cosine, and tangent in blue. Right above them, I have the little minus ones. So if I want the inverse tangent, to get it in blue, I'm going to hit second, and then the tangent button, and notice I get my inverse tangent, and it opens the parentheses. I want the inverse tangent of 12 over 5. So 12 divided by 5. And then I'm going to close my parentheses, even though I may or may not need it. Okay, I'm going to close my parentheses, put that seatbelt on, and when I hit enter, I'm going to get the answer for E. Angle E is 67.3801, blah, 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 degrees. Okay, so it says I want to the nearest degree. That means whole number, which means I don't have to do any decimals. So I look right after that decimal and I see it's only a 3. So I'm going to say 67 degrees. Okay, let's do one more before we move on to the next video. All right, so when I look at the next one, the first thing I'm going to do is highlight or label the hypotenuse. Then I'm going to figure out which angle I'm standing at, and they have it labeled. I'm trying to find X, so I'm standing right here at this angle. I put my pencil down at that angle, and I highlight across that side. That is my adjacent side. And then the side all the way across from me that I haven't labeled yet is the opposite, as far away as it can possibly get, all the way on the opposite side of the triangle. Okay, and then I compare that to so, ka, toa. And this time I know two sides, so those are the two sides that I'm going to be circling. So I know that my hypotenuse is 17, and I know my opposite is 6. I don't know anything about the adjacent, so the 2 that I'm going to use falls under sine. So I know I'm going to be using sine. So normally I would set this up, but since I know I'm looking for the angle, I'm going to go straight to using the inverse. The inverse sine of the ratio, opposite over hypotenuse. My opposite is 6 over the hypotenuse is 17, is going to give me the value for X. So I just have to put this side in the calculator, and that will give me to the nearest degree. So again, I'm looking for the whole number. So inverse sine, so I need to get to that blue, so I'm going to hit the second sine, and then I went 6 over 17. 6 divided by 17, I'm putting that seatbelt on just in case I need it. And when I hit enter, 20.6, that 6 means I need to round up if I want to go to a whole number, so I'm going to say 21 degrees. Okay, in the next video, we will continue looking at more examples using inverse sine, inverse cosine, and inverse tangent to find the rest of these answers. Okay, thank you so much for watching. Come on back for the next video for extra examples.